This movie will explain how DNA is coated onto microprojectiles, commonly known as bullets. These bullets are placed into a gene gun cartridge holder, which is inserted into the gene gun. The gene gun is attached to a helium gas cylinder, and with the aid of a pulse of helium, the bullets are fired into tissue or culture cells. Firstly, I have 25 mg of 1 micrometer gold particles in a tube. I add 50 microliters of spermidine directly into the gold. And then agitate gently. The purpose of spermidine is to help the DNA bind to the gold. Next, I add 50 microliters of DNA into the gold and spermidine. Again doing so with gentle agitation. This is sometimes referred to as a gold slurry. The final step is to add 50 microliters of calcium chloride to the gold slurry. It's important to do this gently, drop by drop, while vortexing the tube. The idea is to precipitate non-binding DNA from the gold. This will stay in the supernatant. The tube is allowed to stand for approximately 10 minutes with brief pulse vortexing every 30 seconds to precipitate the DNA. After 10 minutes, the tube is given a pulse spin to bring down the gold as a pellet. I'm checking there's a pellet. Next, the supernatant needs to be removed. To estimate the efficiency of coating the gold with DNA, a sample of the supernatant can be examined by running in an agarose gel. The pellet needs to be resuspended and transferred into 3.5 ml of ethanol plus PVP. The PVP is a weakly adhesive compound that allows the gold DNA particles to bind to the tubing. I find that a cut-off yellow tip is the best way to transfer the gold DNA into the ethanol. I have already attached a 10 ml syringe to the end of the Teftel tubing, and I use this to transfer the gold DNA suspension into the tubing to start making the bullets. The tubing goes into the modified tube prep station that I designed. And I'm checking that there is a uniform distribution of gold DNA throughout the tubing while removing the ethanol with my other hand via the syringe. What will be left behind is gold DNA particles are lightly adhered to the tubing. The syringe is removed and I switch on the tube prep station at a moderate speed for 30 to 40 seconds with a supply of nitrogen gas flowing at 0.3 litres per minute. The idea is that the gold DNA will spread around the tubing in a uniform fashion and at the same time will dry onto the tubing because of the nitrogen. The nitrogen supply is switched off.
Yes. So
Okay. And again, I'm checking the tubing, making sure that there's a good distribution of gold DNA particles and that there are no clumps. If there are clumps, that's a bad sign. It's referred to as agglomeration, where the ratio of DNA and gold is not correct. The tubing is removed. And is cut to an exact size. Finally, here are a few desiccated gold DNA bullets, ready to go straight into the gene gun cartridge holder, or you can store them at 4 degrees until required.